All right, this is Spring Homework 2, Debriefing. One of the problems said the table shows several coordinates for the function f of x equals x squared. Use the ordered pairs in the table and what you know about inverse. This is graph the function and the inverse of the function y equals plus or minus radical x. Explain your reasoning. Well, so when we're inverting the function, we are reversing it about the line y equals x. Again, I'm just dashing that as a green line on this graph. And that means every value of x becomes replaced with y, and every value of y becomes replaced with x. So think of this as the coordinates to graph. X equals 9, y equals negative 3, which would put us here. X equals 4, y equals negative 2, x equals 1, y equals negative 1, x equals 0, y equals 0, x equals 1, y equals 1, x equals 4, y equals 2, and x equals 9, y equals 3. So I'm going to connect the dots. And this would be the function plus square root of x up above and minus square root of x down below. The original function was x equals negative 3, y equals 9. 1, 2, 3. X equals negative 2, y equals 4. X equals negative 1, y equals 1. X equals 0, y equals 1. X equals 1, y equals 1. X equals 2, y equals 4. X equals 3, y equals 9. And of course, the function doesn't end with the last point plotted. It goes off to infinity. So this is y equals x squared, the original function. Use the ordered pairs in the table and what you know about inverses. I've been there and I've done that. And what's my reasoning? Well, it's the reflection about the green line y equals x. That any point that's touching the line y equals x is going to continue to be touching the line y equals x after reflection. So for example, 0, 0 is on the line, and so is 1, 1. And so after you flip these 2 points, they are still going to be those same coordinates, 0, 0 and 1, 1, even after you reverse them. Okay, I hope that's enough to explain your reasoning. And that's the inverse of the function, okay? So what point or points on the two graphs do they have in common, and why? That's these two guys. Because x and y have same values. So after you swap the value of x with the value of y, it makes no difference. Swapping 0 and 0 is still 0 and 0. Swapping 1 and 1 is still 1 and 1. Number 2, describe the key characteristics of each graph. So for the original function, which I guess I'll do in this color, the original function, the domain was a set of all real numbers. So some of you just write a capital R. Really, you should say it's from negative infinity on the left to positive infinity on the right. That's one way of doing it. Again, some of you write the set of all real numbers. That is an equivalent way of doing this. Now for the range, it only starts at a value of 0 and goes upwards from there. So the range includes 0, so open bracket, comma, but it goes up and up and up without end. So it goes to positive infinity. Think of that as being a positive sign. The x-intercepts. So at what value of x, or what values of x, does y equal to 0? And the answer is, well, at x equals 0, there's an intercept. And at that point, y is equal to 0. What is the value of x when y is equal to 0? What is the y-intercept? Again, these are coordinates. Well, when y is equal to 0, working backwards, the x value is 0. When we take the inverse of this function, so now we're looking only at the green graph, they are asking us to plot both positive and negative square root of it. So this is not a function, but the domain begins at 0 and goes to positive infinity off to the right from there. So the domain is 0, comma, square bracket, and then up to positive infinity from there. Now the range is kind of crazy, right? It goes above 0 and is increasing forever in the positive direction. It never stops increasing. And below 0, it's increasing forever in the negative direction. So trying to mix up my two different minus signs there. But the range is therefore from negative infinity to positive infinity. Where does the green curve cross the x-axis? It crosses the x-axis when x is equal to 0. And what is the value of y at the location where it crosses the x-axis? The answer is, at that location, y is equal to 0. For the y-intercept, they're asking, what is the value of x when this function crosses the y-axis? Well, when y is equal to 0, working backwards, the x value is 0. And so the y-intercept is 0, comma 0. I'd love for you to reason it out that way. All right, next one, number 4. Graph the square root function by restricting the domain of f equals x squared. Okay, so I'm going to restrict the domain to be x strictly greater than or equal to 0. I'm restricting it at its vertex. For these simple parabolas with the vertex at the origin, that means we're restricting it at the origin. But if the vertex is at 3, 2, then you need to restrict your domain at starting at x equals 3 in that example. All right, and they want a graph of the square root of function. If you need to, you can make a brief data table. It says, okay, tell me what the values of x and y are. When x is equal to 0, the square root of 0 is 0. When x is equal to 1, the square root of 1 is 1. When x is equal to 2, the square root of 2 is the square root of 2, 1.414 something, 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 something. When x is equal to 3, the square root of 3 is around 1.73 something. When x is equal to 4, the square root of 4 is 2. When x is equal to 9, the square root of 9 is 3. And that's what we should be graphing, don't you see? So x equals 0, x 0, 0, 1, 1, 2, 1.4, 3, 1.7, 4, 2, 9, 3, and connecting the dots, it goes up like this to infinity. There. That is the graph of square root of x, positive root only. What are the key characteristics of this? Let's see, what else did they ask? Okay, so we are restricting the domain of x squared. If I were to graph x squared one more time with the domain restricted, it would be starting at 0, going through 1, at 9, at 3 it's going to be 9, at 2 it's going to be 4. So this is x squared, and this other one is positive root only of x. So those are the two functions. Oh, I should say the original function in kind of orange, and the inverse of that function Again, it's a reflection about y equals x. Really, it should go through that corner. Okay. All right, so now what is the domain? What are the key characteristics for each function? For the original function, I've restricted the domain to begin at the vertex and go to positive infinity. The range begins at the vertex and goes to positive infinity. The first one, the domain, means infinitely off to the right. The second one, the range, means infinitely up. The x-intercepts are at 0, 0, and the y-intercepts are at 0, 0. And strictly speaking, it's a double intercept because it has two real roots at x equals 0. For the inverse function, its domain begins at 0 and goes off to the right. So again, domain is always the horizontal part of the graph as you look at it. And it begins at 0 and goes off to positive infinity. For the range, it begins at 0 and goes up to positive infinity. So 0 to infinity. Where does it intersect the x-axis? At 0, 0. Where does it intersect the y-axis? At 0, 0. All right, that concludes my debriefing on spring homework 02.